The following content is for entertainment and educational purposes only. It does not constitute means for diagnosis, healthcare advice, nor treatment. Make use of a qualified healthcare professional for such purposes.
So now we can move on to multiple regression. It's very similar to correlation, except it refers to relationships between more than two variables, or at least two or more variables. So we have our predictor variables and our outcome variables once again. Now, instead of the correlation coefficient, we now have the regression coefficient. And this is referred to as the beta. And it's simply the same format where it's measuring the degree to which the predicted variables predict the outcome. So you can see that this follows the same format where the beta's range is also from -1 to +1. And we also need to look at the signs for the direction of the relationship and then the numbers for the strength. Now with multiple regression, because we're dealing with multiple variables, we do have significantly more measures for how to assess that strength. So you can see that a beta less or equal to 0.19 is considered very weak, 0.2 to 0.39 is weak, 0.4 to 0.59 is moderate, and then the very strong beta would be anything greater than 0.8. So if you ever need to decide the strength of this, you can always refer back to the PowerPoint because it's in this slide for reference. And then similar to the coefficient of determination for correlation, we also have the adjusted coefficient of determination for multiple regression. And this then again explains that variance of the predicted variables, which are then explained by the outcome. Yes, Dr. Shaw?
Who can tell me what variance is? The impact of one variable on the other. Who can tell me what that means? Yes, sir.
How much varies?
You're trying to determine whether or not the variability, the impact that that independent variable had upon the dependent variable, how much did it vary? Can it be attributed to that independent variable? So whenever we're doing a regression, let me give you a very colorful example, which is the example that I used last semester. So think about when you find out about a serial killer, right? And we say, well, why did this person become a serial killer? So let's look at the variables, shall we? The independent variables. Somebody would say history of trauma, childhood trauma. Somebody would say that patterns of parenting, right? So that's our second variable. And then our third variable can be violence, witnessing violence. So we have those three variables, and the behavior, which is the dependent variable, is committing murder, right? Becoming a serial killer. When we're looking at variance, we're trying to see if any of these variables contributed to the dependent variable into varying. How much are they contributing to that change? So that's what we refer to as variance. Does that make sense? Any questions about that?
Okay, so now that we've explained the basics of multiple regression, here is what a multiple regression table looks like. It's a lot of numbers, but the best way to do it is just to take it, baby step by baby step. So what you want to focus on are the highlighted boxes. So you can see here, these are the dependent variables: depression, positive affect, negative affect, optimism, and mental health. And then these on the sidebar, those are the independent variables: the identity, sense of coherence, and self-efficacy. So we have our variables, and you can see here again, we have our beta. And these are the numbers that we want to be looking at when we're interpreting this table for the assignment. So before I go into that, if you look at this bottom hand corner with the green box, This is our p-value, and p-value indicates the significance of the results. And we want one that is less than 0.05. That has one asterisk, so it's fairly strong. And then a p-value less than 0.01, that's even stronger. And a p-value less than 0.001, that's very, very good. That's considered, the strongest that you can have. And you can see here that the asterisks correspond to the significance. So for this one with identity, on the impact of depression as a dependent variable, the beta has a p-value of 0.01. So it is significant. Anywhere where you see a number that does not have an asterisk, that means that it is not statistically significant, which is not what we want to be looking at here. We want to look at what is significant, because that will help us with understanding the results and applying that interpretation. Yes, Dr. Shah?
So if you're thinking, well, I already know that the variable, for example, in this case, depression, and we're looking at, say, the variability or the impact that might have had with identity, right? So the case of illustration, we have that beta of -38 with identity. And you're thinking, well, I already have a relationship. Why do I care if it's significant? Well, because when something is related or I should say there is a variance, just because it varied, it doesn't mean that it was indeed significant. And I'll give you an example. Let's use temperature as an example. Maybe outside it drops 3 degrees. So you will see, yeah, there was a change in that beta, right? There was a change, there was a variance, but was it significant? Well, for some of you, you're not going to drop your heavy winter coat, right? Because the change wasn't significant. However, we want to look for that significance because now we do that not only there was a change, there was a variance, but also that it does matter, that it did have an actual impact. So for instance, between you decided I'm just going to wear a hoodie between wearing a heavy coat.
Just follow the format. So basically what we want to look at here are these highlighted boxes. So let's consider identity, the independent variable identity. We can see here that the relationship between identity and depression has a beta coefficient of -0.38. You can see that it is statistically significant with a p-value of less than 0.01. And the relationship between these two variables, between identity and depression, indicates a negative relationship, a negative direction because of this sign. And that makes sense, right? We have to not only look at the numbers, but actually apply this in practical terms. So if you have a greater rates of depression, then your identity, your sense of identity is likely to be lower and vice versa. But then also looking at the strength, it's about moderate in terms of the beta coefficient. So these are the elements that you want to be bringing out in your interpretation of this model. All right, and this is just a slide giving more of an example, a visual example as a reference for how to format your interpretation. So you can see that the independent variables of identity, sense of coherence, these are significant predictors of depression because of those p-values. And then self-efficacy, if we go back and look, you can see that even though it has a -0.01 beta, there is no asterisk by it, which indicates that it's not statistically significant. There is no p-value less than 0.05 at the very least. All right, so another thing that we want to do with our table is also address the variance. So let's go back once more. Under the independent variables, you'll see this light box, the adjusted R-squared correlation or coefficient. You also want to bring this out, and you can see that with depression, the variance can be explained as 39%. And then it's the same format with positive affect, negative affect, optimism, and mental health. So you want to look at these adjusted R-square numbers as well. Yes, Dr. Shah?
So what does that number tell me? It tells me how much that specific variable contributed to that variance, right? So in keeping with our example of serial killers, for example, maybe childhood trauma did have a significant impact, right? It was statistically significant. It was a variance. It was statistically significant. Say, for example, the person's behavior of committing murder. But how much did it contribute? Well, let's say 20%. And then say parenting styles contributed significantly to committing murder, say 40%. So it's a 0.40 variability. That's what that number represents. It tells me how much indeed did it impact my dependent variable. So that's what that number represents, is the how much did it contribute to that variance.
Thank you, Dr. Shar. Also, if you look here, this statement example, it kind of gives a good visual representation of the direction. You can see with the independent variables of sense of coherence and identity satisfaction, it's represented by an upward arrow as it relates to depression, which is then showing as a downward decline. But this basically is just an example of how you would interpret a multiple regression table. But just remember that the important things that you guys just need to be focused on are describing the relationship between the independent variables and the dependent variables. The beta, what that sign means and what that number means in relation to that relationship between the variables, and then the variance represented by the adjusted R-squared. So that's what you guys need to be focused on for your interpretation of this.